Hello friends, welcome to another tutorial in digital electronics. We'll do 3-bit comparator today, and before watching this video I highly recommend that you watch the 2-bit comparator video. You could think of that video as a prerequisite to understanding this one. A 3-bit comparator is a device that would compare essentially two numbers of 3 bits. So we have the first number with A2, A1, A0 bits, and the second number is B2, B1 and B0 bits. So this 3-bit number will be compared to this 3-bit number, and if these two numbers are equal, there is going to be an output here E, which will set itself to 1. If A is greater than B, then there's an output G that will set itself to 1, and if A is less than B, there's going to be an output L which will set itself to 1. So when you take these two sets of inputs together, they will constitute 6 bits. However, if you look at the first combination, when A2, A1, A0 is 0, 0, 0 and B2, B1, B0 is 0, 0, 0. These two bits are equal, so E will be set to 1, and at the same time G will be set to 0, L will be set to 0. Now A is less than B in the second case, so this one will be set to 1 and this will be 0, and so on and so forth. Some random case, if I take for the bits this, you'll find this combination down the line somewhere. So A has now become greater than B, so this bit will be set to 1 and these two will be set to 0. Equal and less than will be zeros and greater than will be 1. So that's the logic that we apply for a 3-bit comparator. If A is greater than B, we set G to 1. If A is less than B, we set L to 1. And with these 6 inputs, we can go all the way from 0 to 63, and you can see that the last input is 1 1 1 1 1 1, so which is also equal, so I've set the E output as 1. Now if you look closely, this has become a classical case of 6 variable K map, where we have 6 variables in the input altogether, and there are 3 outputs. So for each of these outputs, you'll draw 6 variable K map. In the previous video, we have discussed 6 variable K maps in the same playlist, so you could watch that video to draw 6 variable K maps and to solve them. How do we solve them, how do we draw them, and that's all been discussed there. So you could see that if you wish to calculate the values for E, G and L in terms of A2, A1, A0, B2, B1, B0, or in the form of sum of products or product of sums. However, this will result in a 6 variable K maps to be made for G, E and L outputs, and we'll use all these 6 as inputs of 6 variable K map. And another approach is to use a simpler design which will only predict whether A and B are equal. So if A and B are equal, E should set itself to 1, and if they are not equal, it should set itself to 0. And that could be easily implemented using a combination of XOR gates. So I've taken up 3 XOR gates. If you see the MSB of A and MSB of B, second bit of A, second bit of B, LSB of A, LSB of B are fed to 3 XOR gates respectively, and we know that the output of this XOR gate will be 0 only when these two bits are equal. So if all the outputs of the XOR gates are 0, only then we'll get a 1 here, because this is a NOR gate. and if any of these outputs are 1, that goes to show that these two numbers are not equal, so the output final E will be a 0 here. So this is a pretty simple logic, but it's a lot simpler than implementing this 6 variable k-maps. So that is why at a lot of places you see a 3-bit comparator as this simple circuit, which will only predict that it's whether the two numbers are equal or not. So it will compare for equality, not for greater than or less than. However, if you see my previous video where I've discussed 2-bit comparator, I've made up the k-maps for E, G and L for two 2-bit numbers, or in other words they were 4-bit input and 3 output. So I drew k-maps for 3 outputs. Those were 4 variable k-maps, so were easier to design. So you could take up this as the assignment. So you could make 3 k-maps for each E, G and L, and all of them will be 6 variable k-maps. So it will be a very good practice for you to do. And that was it for today's tutorial. If you liked the content, give it a thumbs up, consider subscribing. I'll see you around. Take care. Bye bye.